Hello everyone, in this video we will be going over operators in C++. So an operator is basically a symbol which tells the compiler what type of operation or manipulation that we want to perform. So we'll begin with the different types of operators in C++, which are arithmetic, logical, relational, bitwise, ternary, unary operators, shortcut assignment operators, and there are some other operators specific to C++, such as size of, new, delete, etc. So let's begin with arithmetic operators. As the name suggests, they help us to do arithmetic operations, so which would be addition, subtraction, multiplication, division, and modulo. So modulo symbol is, I assume we are aware of addition, subtraction, multiplication, and division, which allow us to do those specific operations between two operands. The modulo operation, what it does is it returns the remainder given after dividing the two operators. So basically, it returns a remainder rather than the quotient. So the division symbol will, the division operation will give the quotient, and the modulo will give the remainder. Also to note is that modulo operation only works on integers, and also the symbol during the modulo operation depends upon the depends upon the symbol of the left operand. So what I mean by that is, so for the cases in line 17 this one, line 19 this one, the answer will be negative because the symbol of the output will depend upon the the operand which is to the left. So if the symbol of the operand to the left of the modulo symbol is negative, then the answer will be negative as well. You can see those in action. So we see a plus b is 33, a minus b is 9, a times b is 252, a divided by b is 1, a modulo b is 9, because 21 divided by 12 leaves a remainder of 9. Then we see the symbols as well. So a mod b will give us the symbol of 9, minus a mod b is minus 9, a mod minus b is 9, and minus a mod minus b is 9. So here we can conclude that the symbol of the resultant, or the remainder which we get after a modulo symbol, depends upon the symbol of the leftmost operand. Next, let's move on to logical operators. So logical operators allow us to make logical comparisons between two variables. So these include greater than, lesser than, greater than or equal to, lesser than or equal to, equal to. It's a comparison operator called double equal to. We write it as double equal to. It basically compares if the values of two variables are equal or not, and this is not equal to, wherein we see if the value of two variables is not equal to each other. So an example where logical operators are used is in if else statements or any conditional statement where we need to take a decision. So here what we do is we check if a is greater than b. If it is so, then we print out a is greater, else we'll print out b is greater. So we see that over here also I tried printing the output of this logical operation. So the logical operation a greater than b, given a is 21, b is 12, we see a greater than b is true, and hence we are seeing a positive number here, 1. And also the result is a is greater. Similarly, we can have different operations such as a greater than or equal to b, a less than or equal to b, a double equal to b. What it does is it will check if the values stored in a and b are equal. So it shows b is greater. That is because a is 21, b is 12. They are not equal, and hence this output will be printed. And let's also check not equal to. This is because of a plugin which I have installed. Otherwise, not equal to will be written as an exclamation mark followed by an equal to symbol. So not equal to. So we see it's printing a is greater. This is because a has 21, b has 12, and they are actually not equal. So this the output of this logical expression will be true, and hence this statement will be executed. Moving on to relational operators. So relational operators allow us to combine one or more logical operations or one or more conditions. So in this case, what I'm doing is, in this example, we see that if A is greater than B and B is not equal to 0, then we perform the first operation, otherwise we perform the second operation. So the different relational operators are and this is an ampersand symbol. Two ampersand symbols form the logical and. This is an or symbol, so this is logical or, and this is not. So and, or, and not. The truth tables for and, or, not will be: and condition will be true if and only if both the conditions are true. So if both the conditions to the left and right of this symbol are true, only then will the resultant expression be true. Or how logical or works is that if either or any of these two conditions are true, so either one could be true or both are true, in such a case will the resultant be false. And not basically is just opposite of whatever is given. So not true will be false and not false will be true. So that's how you would use relational operators in order to combine many logical statements together. So let's we see that the okay, so I forgot to write. So we see that result 1 is being printed. So we have A as A equal to 21 and B equal to 12. So is A greater than B? True. So this will be true. And is B not equal to 0? Is we see that B is 12, which is indeed not equal to 0. So we have true. Since both the cases are true, our output is true. So this entire expression evaluates to true, and hence the first condition will be executed. Now what happens if the first condition itself is false? So in this case, A is less than B. Is A less than B? Is 21 less than 12? No. So we'll have false. And so in such cases, when we are using the AND operator, if the first expression itself fails, it does not go on to evaluate the second expression. So if I actually am assigning something over here, say B equal to 0, what will happen is it will check the first condition. Let's try and print out B and let's see what happens. Oh, sorry. Even this one. Okay, so right. So we see 12 is being printed. Why is that? So let's see. A is 21, B is 12. Is A less than B? No. So this is false. So once it encounters false, it does not go on to actually evaluate this expression. And in this expression, what we are doing is we are simply setting the value of B to be 0. So in such a case, what we do get is that the entire statement goes false and we print the value of B, which indeed is 12. What happens if I do it A greater than B equal to 0? A greater than B and B is 0. So we see that B's value actually changes to 0. Why is that? Because after the first expression is evaluated, it is true. Then it goes on to evaluate the second expression, wherein we are just assigning the value of B to 0, and hence this actual expression will fail because B equal to 0. What this will do is finally it will substitute B itself in the expression, and since B is 0, this will be 0. It's failing, so we can also see that. So let's try and print it something different between both of those. Right. Oh, sorry. B equal to 0. Let's see which of these two lines is actually being performed. Does B equal to 0 over here always become true, or is it false? Let's see. Right. So what we see is A is greater than B, true, and B equal to 0. So what this will do is it will assign B's value to 0. So B now becomes 0 for us. And when it is evaluating the expression, it will evaluate it with the value of B, which is 0. So now 0. So 0 basically represents false again. So in this case, it will be true and false. And since both the conditions are not true, this entire statement will fail and it will go on to perform. It will go on to execute these set of statements. So that was about relational operators. Okay, we can also look at not operators. So not A, not B. Not of A greater than B. What does this do? If A is greater than B, what will this logical expression evaluate to? If A is greater than B, then it will be true, and not true will be false. So this entire expression will be false, and this block of code will be executed. Now, we move on to bitwise operators. Similar to what we saw in relational operators, bitwise operators do the same functionality, but they work on individual bits. So this is called a bitwise AND, bitwise OR. This is used to perform the mathematical XOR operation between two numbers. This is called the left shift, this is called right shift, and this is called negation. So AND will go on to perform bitwise AND of all the bits in these two numbers, or will perform the bitwise OR. This will perform the XOR. And what this value does is it shifts all the bits to the left by the amount being specified. So for example, this here in this example, we are using the right shift operator. So given 4 is represented as, what this will do is, after having shifted it, if I do this operation shift by 1, my output will be something like 0 0 0 1 0. So this is what left shift does. This is what right shift does. If I do it 2, then the entire thing will shift by 2 places and it will become 1 in this case. Similarly, we have left shift. In left shift, what it does is, so the number 2 is represented as so. If I shift it to the left by 1, what I get is 0 1 0 0. If I shift it by 2, I would get 1 0 0 0. So on. So we can observe those changes here, wherein 2 or 1 will give us 3. 2 and 1 will be 0 because they do not have any bits in common. So doing a bitwise AND of all the corresponding bits will give us 0. 2 XOR 1 will be 3. 4 right shift by 1 will give us 2. 2 right shift by 1 will give us 4, as we had explained. Next, we move on to ternary operator. Let's see what this if else statement is doing. So what it does is it compares the values of A and B. If A is greater than B, then C will get the value of A, otherwise C will get the value of B. Basically what we are doing is, amongst these two numbers, we are storing the greatest number in variable C. We see that for such a simple logic, we are actually having to write quite a few number of lines of code. So what ternary operator does is it simplifies writing such rather simpler if else logic. So this would be the syntax for the ternary operator, where there is a condition followed by a question mark, and then there will be an expression 1 followed by a semicolon, following which will be an expression 2. If the condition is true, expression 1 will be performed. Otherwise, expression 2 will be performed. This is used using assignment. So C equal to A greater than B. If A is greater than B, what we do is we send the value of A to C. Otherwise, we assign the value of B to C. So this entire if block could be written in one single line using the ternary operator. Next, we move on to the unary operators. So till now, almost all the operators we saw are binary in nature, meaning they require two operands to work on. So we see that we actually require 2 and 1 in order to perform this entire operation. Similarly, in order to compare two variables, we need to have two variables. What unary operator does is it does not require two operands to work on it. Hence, it can work on one operand on its own. There are two types. There are two ways to use the unary operator. It's called while incrementing it, it's called post increment and pre increment. This is called post decrement and pre decrement. So say I have the value of a assigned as 1, and what I'm doing is c equal to a plus plus. So intuitively, what you would guess is plus plus would eventually lead to increment of the value of that operand. So if I'm doing a plus plus, this should be similar to a equal to a plus 1. Similarly, a minus minus will also be similar to a is equal to a minus 1, which is true. But the positioning of the operator may change its behavior when we are assigning it to some value. So in these cases, whether I write the operator before or after, it doesn't make any difference to how a is being changed. But when we are trying to assign it to a variable, when we are assigning it to the variable and when we are making a change in a, is that difference is what makes the pre-increment different from post-increment and pre-decrement differ from the post-decrement. So let's see how that change behaves. In case of post-increment, what happens is initially we assign the value to C. So if I'm doing a plus plus, C equal to a plus plus, what I do is I initially give the value of a to C. So in this case, my C will become 1. My C will become okay, let's see. Initially C has some garbage value in it. Let's say C has 0 and A has 1. When we try to execute this statement, what will happen is initially it will assign the value of A to C. So C will then become 1, and then it will go on to increment the value of A. So 2. We'll see that the output is actually 1 for C and 2 for A, as it is observed here. So then what happens in pre-increment? So as you can guess, in pre-increment, we first increment the value of the variable and then we assign that incremented value to our destination. So in this case, what will happen is initially, let's say C is 0 and given A is 1. So what this plus plus A, C equal to plus plus A will do is first it will increment the value of A to 2 and then it will go on to assign whatever value A has onto C. So in this case, our output should be 2, 2, which is visible over here. Similarly, it works the same with decrement operators. So if we are doing a post decrement, it will first C is 0, A is 1. What will it do is it will first assign the value of A to C. C becomes 1 and then it will go on to decrement the value of A to 0. Similarly here, C0, A is 1. Since it's pre-decrement, what it'll do is it'll first decrease the value of A and then it'll go on to assign the value of A to 0, 0, 0. And those outputs are observed over here. Then we come and we can see shortcut assignment operators. So let's say you ever have to write this statement C is equal to C plus 1 or C is equal to C plus 2, C equal to C time c times 2, etc. So instead of having to write so many characters, what we can simply do is we can substitute this with c plus equal to a. This can be written as c plus equal to 2, and this can be written as c star equal to 2. This also goes for other uh, bitwise operators as well. Now let's look into some other random operators which cannot actually be classified to either shortcut assignment, arithmetic, etc. So first we have the size of operator. So the size of operator is used to find the size occupied by a variable or a data type in bytes. So what this will do is, since a is a variable of integer data type, what it will do is it will go and print the it'll go and print the number of bytes which that integer data type will occupy, which in this case is 4 bytes. Next, we talk about the pointer related operators. No, let's first go on with dynamic memory allocation operators, which is new and delete. These will be discussed in detail much later, but what basically they do is new allows us to create or manually dynamically allocate some space for a variable, and delete allows us to free that allocated space. The address of operator, what it does is it returns the address at which the variable is storing its value. So what PTR in this case will store will be the address of the variable a. Similarly, what is used along with the address of operator is also the dereferencing operator or the value at operator. What this does is it is used to access the value at okay, so PTR is storing an address. So what star PTR does is it helps us to access the value which is present at that address which PTR is storing. Also, we have a few more operators, which is the arrow operator and dot operator, which are basically used to dereference or access uh, so the arrow and the dot operators are used in respect to in respect to structures. Okay. The arrow and the dot operator are used with relation to structures and unions, wherein if we are accessing the structure using a pointer, in order to access the internal elements present in the structure, we will use the arrow operator. But in case we are directly accessing the uh, data members of that structure, we will use the dot operator. Now let's go on to see what actually operator precedence is. As you can see in this diagram, we have many operators which we have been using, which we have discussed. And what happens if we have multiple such operators in succession? So do we simply go around and perform perform the operation related to an operator as they appear from left to right, or do we go from right to left, or is there any specific order to follow? And also, among the different type of operators, such as what if we have a combination of arithmetic and logical operators, which operators should be given more preference? Should we do the logical operations first and then go on with the arithmetic operations, or should the arithmetic operation should get done over first, and so on? So in this chart, you can clearly see what operators clearly take precedence over others. And if there are many such operators in the same line, then we have the associativity with which we perform those operations. So for example, for the increment and decrement postfix and suffix operators, the associativity is left to right. So whatever operator appears to the left is executed first, followed by right, and so on. But when it comes to prefix, increment and decrement, we go from right to left. For most logical and arithmetic operators, we go from left to right. We see that pointer to member variables, pointer to member operator is given more preference than certain arithmetic operators. Certain arithmetic operators such as multiplication, division, modulo are given more priority than addition and subtraction, which are given more priority than the bitwise operators, which are given more priority than the relational operators, etc. So this gives us an idea of how the compiler will actually go on and evaluate expressions which contain multiple operators throughout. This was all about operators in C++. Thank you.